Hey students, this is Mr. Winter here. This is Mr. Winter here, just taking a look at the assignment from Monday 125. There's three parts to the assignment, and the first one is this equation right here that says we are going to test solutions to linear equations. So let's take a look at this problem and we'll practice. So as always, you can click on the watch help video right here, and you can get some extended time watching a few of these things happening. And again, if you get the answer wrong, it walks you through it one more time so you can take these down in your notes. And remember, learning happens from working through your mistakes. Okay? So this question says, which of the following equations represents a line that passes through the points 4, -4 and 8, -9? Well, we are testing solutions. So how do we test solutions? We take our x and y values, right? This is an x value, this is an x value, and then our y values right here. This is a y value, and this is the y value. And we're going to plug them into both of these equations and see how they work, okay? And then we're going to decide, do both of these points work in 1, 2, both, or neither, all right? And so take a moment, orient yourself, get these equations written down in your notes, and then we'll try it out. All right, so I'm going to test in this first equation. I'm just going to label everything. I'm going to put the Roman numeral 1 so that we know that we're working on this question. Y plus 4 equals 5/4 -5/4 times the quantity x minus 4. So I'm going to plug in 4, -4 into this equation. So my x value is 4, my y value is -4. Right. Y is going to go here, x is going to go here. All right. So the y is -4. That's -4 plus 4. I'm just going to put the parenthesis around so you know that I did it there. -5/4 times, this is where the 4 goes, 4 minus 4. Again, that's the x value, there's the y value. And let's work this out. -4 plus 4 is 0. -5/4 stays on the outside until we do what's inside the parentheses. 4 minus 4 is 0. All right, well that's -5/4 times 0, which is also 0. So does 0 equal 0? Yes, it does. All right, so we know that this equation works in problem 1. All right, let's try problem 2. We have y equals 5/4 times x plus 1. I put the parentheses there because it helps my brain think through it. So our y value is -4 equals 5/4. Our x value is 4 plus 1. So 5/4 times 4. Remember, when you multiply and divide by 4, it eliminates, but if you can't see that, just do 5 times 4 is 20. 20 divided by 4 is 5. So you see, times 4 divided by 4 just gets us right back to 5. We get 5 plus 1. Does that equal -4? And the answer is no, right? 6 does not equal -4. And so I like to not put this equal sign here because we're just trying to figure out, is it equal? And this one it's not. So it worked. This one worked for 1, but it didn't work for 2. Let's see how we do on the next part. And so problem 1, y plus 4 equals -5/4 x minus 4. We're going to plug in our next value, 8, -9. Let's see. So this is my x value. It's going to go in right here. So the 8's going to go in right there. -9 is our y value. It's going to go in right there. All right. So you can see we have -9 plus 4 equals -5/4 times 8 minus 4. So now we just need to do the math. -9 plus 4 on this side is a -5. That equals -5/4. What's 8 minus 4? Well, that's 4. All right, and so we're going to say, work this out the same way. We're multiplying and dividing by 4. So they cancel each other out. But if you can't see it, 5 times 4 is 20. 20 divided by 4 is 5 with that negative sign in front. So we get negative 5 equals negative 5. Hey, so look at that. It works. This solution works in problem 1. Okay? Now we can try out the second one, but we know, well, let's just try out the second one for practice. So problem 2 is y equals 5 over 4x plus 1. Let's put in our negative 9 for y, our 8 for x. All right, and I'm going to write in the rest of this and move my head so you can see it. All right, let's move this over here. All right, and so let's do the multiplication. 5 times 8 is 40. 40 divided by 4 is 10. So we get 10 plus 1. Does that equal negative 9? Well, negative 9 does not equal 11, so the answer is no. And so our solution is it works in 1 only. So let me pull this up for you so you can see it. I'm going to go down here and click 1 only, submit my answer, and boom, I got the green check mark. Now it walks you through that same stuff I just did. So you can look through the notes here, take in a moment, pause this if you want to write these down. All right, so it's true on equation 1. Equation 2, it's false. So it does not pass through both points. It only passes through point, or the first equation, right? The first point is the only one both equations pass through. All right, I hope that helps you with that problem. We can try one more here quickly. New problem, and you can see which of the following equations represents a line that passes through the points 2, negative 1 and 0, negative 5. I'm going to all right, so here we are with this second problem. I want you to just take a look, write this down, okay? The two equations, 2x minus y equals 5 and y equals 2x minus 5, and then test these points. Okay, pause it, and then come back and see the answer. All right, hopefully you did this on your own, tried it out, determined if it works for 1 or 2. So this is my x value and my y value. The 2, negative 1, I'm going to plug it into the first equation. 2 goes in here, negative 1 goes in here. Notice that negative and this negative. Think about what that double negative is going to do. All right, and so we get 2 times 2 minus negative 1. So see how if you use those brackets, you can see that double negative right away. That's how I like to do it to organize what I'm plugging in. Sometimes it doesn't work as well, but think about keeping everything organized. So 2 times 2 is 4. Negative minus negative 1 means plus 1. So does 4 plus 1 equal 5? Sure does. That is true. Let's plug in x here and negative 5 in for y. Again, the negative 5 is showing up again. So let's do 2 times 0 minus negative 5 equals 5. 2 times 0 is 0. Minus negative 5 is plus 5. And look at that. Is 5 equal to 5? Boom. Both of those are true. All right, so now go ahead and plug into equation 2. If you haven't already, I'm going to pause this and get it set up. All right, so hopefully you got a moment to look at this, try it out again. The second one, remember, x goes in for x, y goes in for y. Oop. Look at what I did. I messed up. I put the first equation there, so I'm going to erase that for a second. Put the second equation in for the next one, but always double check what you're doing, because you can see even I make mistakes often. All right, so x goes in for x, y goes in for y, x goes in for x, y goes in for y. So this negative 1 is in for y. The x, 2 times 2 minus 5. All right, so negative 1, is that equal to 4 minus 5? Yep, if I'm at 4 and I go subtract 5, I go in the negative direction, past 0 to negative 1. So this one works. Negative 1 is equal to negative 1. And then we plug in the negative 5 here for y. 2 times 0 minus 5. And you can see 2 times 0 is 0. 0 minus 5 is negative 5. So yes, it is true for this equation as well. All right, I'm hoping that helps you. One other just side note here, look at these two equations. Do you see how similar they look? Right, I have 2x minus y equals 5. That's messy. So I have 2x minus y, that equals 5. Well, does it look anything like this? Watch this. If I add y to both sides, I get 2x equals 5 plus y. Subtract 5 from both sides, and I get 2x minus 5 equals y. If I rearrange that, right, y equals 2x minus 5, notice how this first equation and the second equation are identical, they're just rearranged. So that could tell you that it works for both of them too. And so let's pull this up. Oh, it's not working for me. There we go. Here's our question. We're going to say it works for both of them. Submit that answer. And boom. And it walks you back through this. It does pass through both equations. So hopefully that's helpful. We're going to take a look at the rest of this assignment. All right, so this one's best done right in the system here. So we have two equations, y equals x plus 3 and y equals negative 3/2 x minus 7. So the best way to graph these problems is to think about the y-intercepts and the slope, right? Because they're written in slope-intercept form. So this first equation, the y-intercept is 3, so click on 0, 3. And then the slope in front of x is 1. So that means it's going to go up 1 over 1, up 1 over 1, up 1 over 1, and you can graph those that line with those 2 points, and it does it for you. The second line then has a y-intercept of negative 7. So you go down to negative 7, and look at the slope. It says negative 3 over 2. So if you remember, that means we started our y-intercept, we go down 3, right 2. And you have these 2 points. So then, once we have those 2 points, we look at where do they intersect. And it won't let us just click on that point. And so you have to think, what's the x value? So I start at the origin, I go left to negative 4, and then down to negative 1. So our value is negative 4, negative 1. That is the solution to this set of lines. So click Submit Answer. Yes. And this really shows us how well you're doing in this concept. Both graphing the lines and then finding their intersection point. If you don't do it correctly right away, practice, see what you did wrong, and come to office hours if you need more help on this. Okay, this is one of these critical skills, both graphing and finding the intersection point on a graph, that we're going to make sure that you have down before we let you just move on in this skill. Okay, we're going to also do one substitution problem here. So if you take a look at this problem, I want you to pause this after you write this down and try it out on your own. I'm going to pause it and set it up in my Sketchpad. So we have a y equals an equation, right? We call this slope-intercept form. And then we have what's in standard form here. So it's really easy to take what y is equal to and then substitute it in for y in our second equation. So go ahead and try that. Hit pause right now, and then come back and see if you did it correctly. All right, so do you see what I did? We said 10x minus 10y, but in place of the y, we put in the negative 7x plus 4. So notice that negative 7x plus 4 right here is substituted, thus the... All right, so we jumped ahead here because I ran out of time. So I kind of want you to walk through this, right? We inserted negative 7x plus 4 in for y, and then these are all the steps that we completed. All right, make sure we're distributing with this negative. So we get negative times a negative is positive 70x minus 40. And if you work through these steps, hit pause, walk through it, you see that x is 1. Then we take our first equation, y equals negative 7x plus 4. We're going to insert x is 1 into here, and we get negative 7 times 1 plus 4. So negative 7 plus 4, negative 7 times 1 is negative 7. We get negative 3. So our x value is 1, our y value is negative 3, and we're going to take that and we're going to plug it into our question, our Delta Math question, and show how we did. So what do we say? 1, negative 3, 1, negative 3. Yes, we want to try that, and we get the correct answer. And this will walk you through it one more time. Now, Come to office hours if you need more help. Watch the videos. You got this, all right? It's all about learning.